The main problem with MCP is that when you connect to the server, it loads all those tool descriptions and all the tools all at once, right? So you can end up with like consuming 20% of your context window just by loading MCP servers, right? I think that's why a lot of people that have tried to, they wanted to have an agent that had like 100 tools, realize like, oh, this is causing more hallucinations because they were using so much of the context window just for the MCP connection. So there's only so much that you can do by just looking at structure. And also, as instance models grows, imagine if that unified namespace or whatever your instance model is, it's probably not that big of a deal for an agent to reason on that if it's small, like maybe, a few production lines. But you imagine a huge enterprise with multi-site, multi-area that maybe has thousands of pieces of equipment. That instance data, it becomes such a large size. The agent's gonna lose kind of awareness of where it's at in that data, right? But the beauty of that is that skill is now packaged in a way that other agents can use it, right? So I can have all these skills and they can be very like, modular and composable. And then an agent can just read those into the system context window to be able to execute it, right? So you can have this kind of like polymorphism with agents with things like skills because skills are encapsulated logic, which create some really powerful design patterns.
All right. Welcome to the AI in Manufacturing podcast here on Industry4.tv. My name is Kudzai Manditereza. I'm your host. And in this episode, we will discuss AI context engineering for manufacturing and data architecture for operational intelligence in industry. And my guest on this episode is Zach Etier, who is the VP of Architecture at Flow Software. Did I get that right? I think you're the VP of
Yep, you
Architecture
nailed
today,
it.
right?
Yep, yeah, you nailed it.
Wonderful.
So
Yeah, I mean, yeah, welcome to the show, Zach. Really appreciate it, and it's so exciting to have you today.
yeah, no, absolutely. Thank you for having me on the show. I'm super excited to talk about agents and anything else we do. So thanks for having me.
So maybe before we really, dive into it, could you start by introducing yourself to audience? Tell us a bit more about who you are, your background, and your current role.
Yeah, no, absolutely. So I've been at Flow for about just little over a year now. As you mentioned, I'm the VP of architecture. So my main role is to be thinking about, where's industry going? What type of pain points are stakeholders in industry going to be facing that we might be able to develop solutions for? And then those solutions, how do we design them so that they're scalable, maintainable, add the ability to, add governance into them, things like that. One of the main product lines that I focus on and kind of the main reason I was hired is everyone knows us for Timebase as the historian. Timebase is actually a product line. So we actually have plans for a few new products under the kind of tag Timebase, but it's a product line. One of those tools is a knowledge modeling tool called Atlas. And we kind of gave a teaser at ICC about what Atlas is. It's essentially a knowledge modeling tool where you're able to develop a knowledge graph. But that's kind of my big part of working at Flow is leading the development of that knowledge graph technology. Outside of that, I've been kind of involved with the agent design, kind of thinking about how do we implement AI into our products. There's a lot of hype in the industry about AI right now. Where can we actually find the value, right? I think there's a lot of people injecting agents into talk with their data, but are there actual use cases where agents or AI can do like more complex things that like add a lot of value to organizations, right? So thinking through that, kind of thinking about how do we build that into our products, and then also how do we build agentic pipelines and things that help us internally at Flow. So actually do a lot of internal tooling for AI, adding agents to our CI/CD pipelines. How can we do it? How can we implement agents to help with documentation? Kind of things that we as developers don't necessarily like to do all the time, but it needs to be done. And those are great use cases for agents, right? So kind of be developing some of that internal tooling at Flow. Before Flow, I was at Northrop Grumman for 10 years. Started off pretty fresh out of college, leading an additive manufacturing lab at Northrop Grumman out of Phoenix. We had mostly FDM printers, so plastic FDM printing. Did 20,000 prints per year, so pretty big volume. That was a great learning opportunity for me to really understand how the factory works. Always getting pulled by different programs that need prioritization. You have one that someone told me they need it today, and then someone comes in and says they needed a part yesterday. So how do you balance that? How do you work from a scheduling point of view? That was a really good experience for me, learning how factories actually work. Um, my background is traditional engineering, so I have a degree in mechanical engineering, aerospace engineering, but also computer science. So after the additive manufacturing lab, I actually went to corporate Northrop, under the CIO office to work on digital manufacturing, for their new OT service line. So they're trying to develop a new service line to help bring Industry 4.0 architecture that sites can adopt and use and align them so that they're interoperable and, different sites can interact and be able to integrate each other's data. Outside of work, live in Tulsa, Oklahoma. I have a wife. We've been married for about 10 years now, and we have a 3-year-old daughter. So, been learning how to balance work-life balance
Yeah.
and, work in industry, but also try to be a good dad. So that's been a really good opportunity. A lot of good lessons learned there. But yeah, that's kind of me.
Yeah, absolutely. Yeah, I mean, I can, certainly relate with trying to balance. I'm myself a new father of a 2-year-old son now, so
Oh, nice.
it's really exciting times. And yeah, absolutely. So, I mean, you mentioned really, AI agents there, and this is a term that, I mean, it gets thrown around a lot, right now, from
Yep.
chatbots, fully autonomous systems. So what I want sort of like you to do here for us is kind of like take a step back before we go really more into exactly how we can build those. Sort of like give us a definition of when we talk about an AI agent, specifically for the industrial context. What does that actually mean to you?
Yeah, no, that's a great way to kind of ground and make sure that we're talking about the right things from a semantics point of view, right? It's always kind of funny how language works. People invent terms because it helps identify like a common experience or something that we don't have words for. But as more people adopt those words, more people use it outside the context it was initially made for, right? So a lot of people using agents, maybe using it in an incorrect way. It becomes hard to understand what's the difference between, a co-pilot, a chatbot, an agent, industrial agent, right? Maybe the best place to start is talking about what's a general agent is, right? Um, you know, 2025 was really the year of the agents. And the main difference from an LLM, like a chatbot like ChatGPT, and an agent is that agent has the ability to act on the world, right? That's really what's in the definition of an agent. And the way it does that is through tools, right? An agent really has two main components I would use to define it. It has a intelligence component, so you can think that's the actual model, right? Opus, Gemini. It's a thing that adds the ability to reason on the context. But then you have these tools that allow the agent to interact on things, right? So I have a tool that can retrieve data from a database, or if the agent needs more context about the domain, it can call a tool to read a document, maybe a like equipment manual to understand, context about that piece of equipment, right? So to me, the way I would define an agent is very simple. It's essentially just an agent that is able to, or it's an LLM that's able to call tools in a loop, essentially. And that is the key piece of, to me, like what an agent actually is. An agent is really determining, kind of the way I think about it, it's really an orchestrator, right? It's determining, well, what tool is the next tool that I should call? Should I go get more context and read a document? Should I do a tool call to read data out of a database? Should I call a tool to, generate a report or write some type of file, right? That the agent's becoming this orchestrator, that is able to reason on data to really make determination of what the next step should be, to complete a task, essentially. Um, so that's kind of how I define a general agent. To me, an industrial agent, is just one that's closer to the domain, right? You can imagine an agent that's been developed for deep research versus an agent that's been designed to interact with a historian. It's going to have very different tooling, right? The tooling on an industrial agent is going to be, how do I read that historian data, and then how do I aggregate it so I'm not reading 10,000 rows of data. The tooling and the context that agent's going to operate on is going to be very specific to the domain. Whereas like a general agent, like, Claude Code or maybe a Codex, it's going to be more generalized, right? It's going to be, not as close to any specific domain. That industrial agent's really kind of a domain experts in industry and has specialized tooling to allow it to interact with that environment. So that's kind of how I would define an industrial agent.
Yeah. And then maybe to kind of like make it a bit concrete for our audience, could you give us maybe an example of what an industrial AI agent would do or would perform?
Yeah, no, absolutely. We actually had in the Prove It workshop, I actually had a demo where I actually kind of showcase a use case. So in the demo, I actually had a handover report, right? For a shift change, essentially. And actually had an agent that generated that report that pulled in context from different things, right? So it pulled in context from a historian database to aggregate to see if there was any faults during the previous shift. It actually pulled in context from operator notes to see did the operators have any comments or anything that was out of the ordinary. It pulled in context from the unified namespace for I think it was MES data and then some of the PLC data, right? Um, it then generated a shift report that aggregated all that data together and then provided a way for when shift changes happen to be able to do a shift change where there's a report that adds a lot of context for the team coming in to see, okay, what actually happened. And it's very passive, right? We didn't have to go generate that report. We didn't have to go generate those things. They're kind of happening in the back passively, which is where I think a lot of the value comes from, right? A lot of the value comes from these things happening in the background and then it's just there when we need it, right? But yeah, that was a good example of maybe an agent that can generate like a handover report, and we did it in the workshop for Prove It.
Yeah, absolutely. Yeah, we're going to get into in like a bit of more detail into exactly the different kinds of contexts that an agent could leverage. But before we do that, so basically, an agent is you give it a set of instructions, right? So
Mm,
it's working off of an instruction to say this
yep.
is what you need to do. Could you sort of like uh, because I think this is where you sort of like are talking about this idea of moving from prompt engineering to context engineering, because currently how you'd interact with an agent, or maybe traditionally with prompt engineering, how people normally just type into chat gpt or cloud code
Hmm.
to say, hey, can you do a b c and d for me? And the misconception that I would like you to sort of like clarify for us is that the more data that you give the agent as an instruction, the better it will perform. And
Hmm.
that's kind of like the crux for you of this idea of context engineering, to say actually that's not the case. Can you
Yep.
unpack for us on why that is, why more data is actually a better idea for an agent?
Yeah, no, absolutely. So I love talking about context engineering. So that's a great question. There's a few kind of underlying questions. Maybe kind of address each one at a time.
Mhm.
As far as the question of like, well, okay, what's the difference between like prompt engineering versus like agent, where we're doing this like context engineering, right? Rewind back to 2024 when most people are using open AI, chat GBT and, maybe Gemini. They're interacting with an agent, or sorry, with an LLM through a chat interface, right? That model, receives an input string and then it generates, predicts the next token. And then it does that several times to generate a response essentially. But there's no like intermediate step in there. It doesn't actually like show its work of like, okay, this is how I got to that solution. It kind of just generates a solution, right? And that's kind of a characteristic of transformer multi-attention head or multi-headed attention architectures that we have now. Um, because of that, we had to be very specific, right? There was no way to add or call tools. We had to basically think about in the prompt, okay, how do we structure the prompt? How do we make it very clear what we're asking for? So we were thinking about like language or the structure of, the actual prompt. We had to add context to the prompt, right? There was no tool calls. So we actually had to like, copy paste maybe code snippets or, things from a web page into
Yeah.
that prompt, right? So there was kind of some context engineering going on, but it was very much just a prompt and then, submitting that and then getting a response. really, I think where things changed and how we got into context engineering is when reasoning models came out. So when models came out, they're pretty much the same architecture as non-reasoning models from, a transformer point of view. The main difference is how they're trained. So they're actually trained with basically where the training data fine-tunes to actually show its work. So instead of it just producing a final answer, the response actually shows its work, and then it provides an answer. Well, because of that, now we can actually introduce tool calls, right? So when reasoning models came out and really chain of thought came out, that's when we actually saw tool calls. And once we saw tool calls, that's when we got into the kind of the prime of agents, right? Now that we can actually have agents that tell us what their plan of attack is or show their worth. Now that they can call tools as part of that response, and then get to a final answer. So what that actually meant is now no longer are we inserting that all into a prompt. Maybe the prompt starts the chain, kind of to your point, earlier about, we kind of give it a task. But then the agent is showing its work. It's actually calling tools and it's pulling in dynamic data, right? The prompt engineering is very static, kind of you submit it and then it generates. Context and pulling in from tool calls is very dynamic. Data changes in databases, files get updated, get moved around, right? New files get created, right? We create new context or
Yeah.
new business logic all the time. So that agent is constantly, pulling in information. Because of that, it's a lot more dynamic and it ends up kind of with the steering feature. Um, so that second question is, okay, well, where's context engineering coming in? And, why did we think initially like, oh, giving as much context as possible is going to be valuable, right? Well, just like we think, okay, we want as much coverage or as much context as possible to the agent, right? And I think in early 2025, that was kind of the main takeaway people would give is, give it as much context as possible. And to me, it makes, perfect sense, but we were seeing pretty bad results, right? It's something that I personally, from my own testing, was seeing that, a lot of times it would hallucinate or it wouldn't do exactly what I wanted it to do. So a lot of research actually went on in 2025 around context engineering and like what's actually happening in the context window. And essentially, they're with transformer architectures with attention blocks, um, the more tokens that you add through the context window, the more the relevant information gets diluted because of the normalization process, which is called softmax, right? So if you have, some very relevant information, but then you add a ton of tokens, all that relevant information gets watered down, and then the agent doesn't focus on it as much, right? So it's basically not able to determine what's the difference between like highly relevant information and like what's noise, essentially. Like we think it's added benefit, but it's really just diluting the things that really matter in the context window, right? And
Mm.
there were some other studies that went on. There's one that's very popular called "Lost in the Middle." I think it was a Stanford paper. They actually found out they did what's called the needle in a haystack test. So they insert a text at various parts of a document. So they did it at the start of the document, at the middle of the document, and at the end of the document. And then they also did it for different document sizes. But they actually, tell the agent to read the document, and then they ask it a question that would require it to recall that prompt that they injected in the middle or start or at the end of the document. And what they found is kind of like humans, when we go to a presentation, people usually remember the start of the presentation or the end of the
Yeah.
presentation. Agents are the same. The first few tokens really impact the trajectory of the LLM. So kind of where the future responses are going to go from them. And then the last tokens have a recency bonus. So your last prompt is always typically going to have higher weight than things in the middle. And then things in the middle kind of get lost. So you can imagine if you just pump this context window with, as much context as possible, that middle section is going to grow. And then that means you're going to end up losing more context. So even if it's in the context window, and you're also getting charged for it, right? You're getting charged by the number of tokens you're submitting to it. So you're paying for it. The LLM is actually not able to reason on that, which causes it to hallucinate. As instructions move into that middle section, it's going to forget that it had that instruction, right? So it kind of leads to this need to manage the context window, right? Oh, were you
Yeah.
going to say something?
Yeah, absolutely. I was gonna say, it's very interesting, but maybe to make it tangible for our audience, kind of like paint a picture of what are these actual pieces of content or of sort of a context that an agent would actually need, maybe in an
Mm.
industrial environment. So to kind of like to paint a picture of how blotted that context window would become if you throw all of these different pieces of context to the agent. Can you give us a sense of what are those different pieces of context that typically you'd want to include in an industrial AI agent?
Yeah, no, that's a great question. So when it comes to context, there's a few different definitions of context that I think are out there. So maybe start by calibrating on when I mean context, how would I define it? Essentially, for me, context is a form of knowledge. So you can think of, knowledge are facts about our domain, right? The sky is blue or the grass is green. Those are facts about our, environment or the world. Same thing with manufacturing domains, right? We have facts about how our operations are structured, how our product lines are structured, right? And there's kind of these domain facts or knowledge about the domain that are very important. But the difference between context and knowledge is context is curated knowledge that is curated and packaged for a specific task, right? So, for example, using the example of maybe I need to maintain a piece of equipment, I could read the whole equipment manual that would probably fill up the entire context window, right? Which means I wouldn't be able to do anything with the agent after I read that document. If I'm trying to troubleshoot for a specific thing, I don't need to read the whole document, right? I only need to read the sections of the equipment manual. They're going to give me information or knowledge that I needed to do my specific task, right? So to me, the whole document is maybe, knowledge about the piece of equipment, but the context is me filtering and getting that knowledge that's from that document that's specific to the task that I'm trying to do, which is debug a specific, issue. So that's how I would define context. So to me, there's a few categories of context that an agent might use. So the one I kind of was talking about there is domain knowledge of, context about the domain or, the thing that the agent is interacting on. And there's also data context, right? So that's kind of the typical context most people think of, when they think of unified namespace or maybe like OPCUA or these other things, right? Being able to see, data, but then also like metadata or PLC data, and then seeing like the work order, MES data right next to that to be able to understand like what was actually happening and get that piece of equipment. So there's data context. But there's also other forms of context that most people don't think about, right? Things that are human generated, things like operator notes or, SharePoint sites, Excel sheets. Those are all forms of context that, provide insights to agents when they're doing their reasoning, right? You can actually pass in an Excel to an agent and it can actually look at how the Excel is structured, see what formulas are being used there. It can look at the business logic of the Excel and actually reason on that to get some pretty good understanding of, what is the person using that Excel trying to do with it, right? So you can have context that's kind of like human generated that most people don't think about. And then the last one I would classify as like context of how I want the agent to operate, right? So if I want the agent to behave a specific way, that's a form of context. Anthropic uses skills. Skills are a form of context, right? They're describing to the agent how I want the agent to behave and guardrails or style constraints that I want to add on it and things like that. Um, so to me, there's a few different categories there. For industrial manufacturing, you're probably going to pull from all of those, right? You're going to have skills that define the agent, how to troubleshoot or how to, read a manual or whatever from a domain. You're going to read domain knowledge, maybe equipment manuals or standard operating procedures for your company. You're going to pull in data from historians or unified namespace to see current state, right? You're going to pull in some of these things. But most agents are going to pull from all those different categories. It's the difference between an industrial agent and a general agent is again, it's specific to manufacturing, right? You're going to have more historian type of tooling or tooling that allows it to integrate with MES systems or ERP systems, things that are more specific to manufacturing than something like a coding agent would.
Yeah, absolutely. So maybe before we go into like the sort of like the techniques for context engineering that you've put out there, maybe I think it's useful to start by defining for audience some of the more common terms out there. You mentioned cloud user skills. There is also MCP tools and things like that. So maybe could you sort of like identify those few key terms that people need to be sort of like have a clear definition of, like, first of all, MCP. What is MCP? What are skills? There's also sub agents and things like that, just to kind of like, set the context for our audience.
Yeah, no, absolutely. So a lot of these are ways that we implement context engineering, right? So context engineering is kind of like a philosophy, and that philosophy of what context engineering is, how can I populate the context window with just enough information for it to do its task? So, very concise, but enough coverage to really be able to do the task, but populated with highly relevant information and no bloat, right? So it's really about curating really highly relevant information and inserting it into that context window. So that's really what context is, that philosophy of managing the context window, essentially, and making sure that the context window has really highly relevant information and no bloat. So some of these terms, like you mentioned, subagents, MCPs, these are ways that we can implement different techniques, right? So when we implement a subagent, we're able to spin up another agent that has no context of our main agent, right? So you might be talking to a main agent and giving it context. It might read tool calls. A sub agent would spin up and it would have no previous history of that chat history, so it wouldn't see any of the context that the main agent would have, right? That's a technique in context engineering that we call isolate, right? You're able to isolate context from different agents by spinning up subagents, right? So a subagent is a way that it's an agent that has its own isolated context window, but that isolated context window is a technique for how we practice context engineering, which is called the technique of isolation, right? MCP is another really popular one. MCP, thinking about an API, the problem with an API is there's only so much that we can get from an API endpoint, right? And sure, an agent could read like a Swagger page or, API documentation to get some understanding of what the API is. But when these models are created, they're not trained on the software that we use, right? They're not trained on like how to use InfluxDB, right? There's some training data out there just because of the internet and, Reddit and people talking about these things. But like for some very nuanced tools, there's really no context for an agent to understand how to use that tool, right? So we need to add context for the agent to tell it like, hey, when you call this tool, this is what the tool does. These are the inputs that you pass into the tool, and this is like why you would call this tool, right? So you add that context to the tool descriptions. And what that does is now when the agent connects to an MCP server, it understands the tools. It understands like, okay, when should I call tool A versus tool B? And if I call tool B, what do I pass into it, right? What are the inputs to that, right? So it's a way for agents to be able to call traditional tools like an API, but differing from an API is that we're able to add more context so that an LLM that's never been trained on using our tool has enough context to know how to use the tool, essentially. So MCP is how we kind of do that context management, and be able to supply that context to agents. Some other ones that are really popular for context engineering, that kind of go back into like, why can't we just pump it with data? A lot of people have probably heard context rot. Context rot is that principle that I was talking about where you dilute the highly relevant tokens from the attention block, essentially. Like you add so much information that the LLM can't reason on it because it's watered down the important topics. It's lost in the noise, right? The other one's context poisoning. So some people have maybe heard of context poisoning. You can think of context poisoning as, let's say when I'm working with an agent, let's say it reads maybe a fact or a piece of context, or maybe it even hallucinates. So it gets something into the context window that's not necessarily true. Even if we try to correct that with a subsequent prompt saying like, hey, you said this isn't true. This is how it should be. That even you correcting that, because that token that's incorrect is still in the context window, it will continue to plague the rest of your responses, right? So that's why even if you tell it like, don't do that, it will still do that sometimes, is because that token's still in the context window, which is influencing the rest of it. So context poisoning, the only way to clear it is to use an isolated context window, because that subagent doesn't have that, token in its context window, or to clear the context window, right? And then the other one is confusion. So context confusion is another popular term. Where context confusion happens is, let's say you have document A and document B, so two forms of context. let's say document A has a contradiction with document B. If the agent reads both documents in there, it doesn't know which one's objectively the truth and which one's false, right? So you can have contradictions where the model has problems reasoning because information's conflicting, right? So those are all kind of terms around context engineering um, that people have probably heard or seen on the internet.
Oh yeah, absolutely. So maybe let's kind of like dive into the three techniques of context engineering that you've sort of like identified for building reliable industrial AI agents. Could you walk us through each one? What they are, how they work, and maybe give us a practical example of each.
Yeah, no, absolutely. So again, context engineering is about filling up the context with highly relevant information. The techniques that I'm going to talk about are just techniques that we can do to do that, essentially, right? So kind of the first one that most people have probably done already is the fact of persisting context to something like the file system, right? So if I'm managing the context window, or I'm trying to practice context engineering, I'll probably clear the context window as the context window fills up, right? And I just need to manage that and clear out the context window. There might be context I want to preserve, right? I don't want to lose that when I clear the session. Maybe I want to preserve that context. And when I clear the session, I want to have the agent read that so that when it's continuing, it's able to kind of follow the logic or have some context that it was able to curate going down the road, right? So there's this. The first technique is writing context essentially, and that's to write context to a file system so that an agent can read it down the road, and that's also relevant for subagents, right? Subagents have isolated context window, but sometimes I might want them to read something another agent generated, right? Well, I can have that agent write a markdown or an XML file or YAML or tune or whatever serialization format I want to use, and then an agent can read that down the road, right? So that's kind of the one of the first and kind of the easiest and kind of the most popular one. Cloud Code and some of these general agents, you'll see they pretty much always generate markdowns or something, and they'll persist it to the file system, right? The second technique, which most of you probably used, but maybe haven't been aware of this, is the idea of summarization or compaction, right? As we fill up the context window, maybe we read a document and we don't need the full context. Like once we've read it, we realize we don't need the full context window. What we can do is we can summarize that context. We can evict, the rest of the context out. And now instead of using like 80,000 tokens, maybe we're just using 5,000 tokens, right? So that's a way to be able to get insights out of context and consolidate so that we're able to treat the context window as kind of a resource that we want to be able to manage. That summarization is able to do compaction essentially. And the reason I say most of you have probably used this, you just didn't were aware of that, is a lot of tools will do auto compaction. So as you fill up the context window, you'll see like Claude Code will say like compacting or whatever. What has happened under the hood is that context window has reached kind of its upper limit, and what the agent's now doing is summarizing. It's taking a best guess of what it thinks is important for another session down the road to be able to know, to follow the train of thought of like what's being worked on, right? So what I'll do is I'll look at the context window, try to figure out what's important, and then summarize that. And then that context will be injected into the next. It'll basically clear the context window, and then it'll inject that summarization into the next context window. Which is also why after auto compaction, a lot of you probably realize like it's totally wrong, right? It might forget instructions. It might be doing something very weird. The reason why is when it does that auto compaction, it might have thought something was irrelevant, but maybe it was relevant and it eliminated from the context window, right? So that summarization is a powerful tool, but it's very tricky, right? How do you look at a document or a form of context and figure out like what is the highly relevant part of this that an agent down the road is going to need, right? It's a very kind of like art to be able to do that. And really it kind of goes to like knowledge modeling and figuring out like when we have something like an equipment manual, like what are the important sections that an agent's going to be able to understand, right? That summarization is a very powerful tool to be able to get insights out and be able to interact with like a lot of context, but in a small window amount, essentially. And then the last one is isolation, right? So this is the one with the subagent that we had talked about. A good example of this is kind of a coding agent, but you could imagine there's a lot of industrial use cases for this. If I want to make a feature change, I first need to tell the agent, or the agent needs context of what files does it need to change to implement a new feature, right? So there's kind of like a research phase that goes on. When it goes and does that research, it's going to read a lot of files that it doesn't really care about, right? It does, maybe it thinks it's a file based off its name that it is relevant, but when it reads the document, maybe it's like, oh, this is something that has nothing to do with the task, right? By just reading that document, that's in the context window, right? So as the research agent, sub agent does its work, it's filling its context window with things that are relevant, but also things that are not relevant, right? I wouldn't want my main agent to have all the non-relevant things in there. So what I can do is I can use a sub agent to do research, to curate and like filter all the files for, okay, what are the relevant files that are actually needed for the feature. The sub agent can go do that work and then return just kind of do summarization, can just return what files the main agent needs to know to be able to go do the feature implementation, right? So you can use isolation to be able to offload tasks so that the main agent, or the agent that's actually doing the work, isn't being bloated with things that aren't relevant for doing its task, like finding files that, we don't want to read files that aren't part of the work that needs to be done, right? That can be delegated to a sub agent. But that isolation is a very powerful tool to be able to offload work and to be able to orchestrate. And that's really why we have these like multi-agent systems that we're starting to see like a lot of people talk about, and be able to show with like deep research and stuff like that.
Yeah, absolutely. So I mean, like, it's really fascinating how you. So I just kind of going through your repo. So we're going to share this also in the description of this podcast for those who want to check that out. But just kind of like how you had this, uh, this separation of concern, for like for a better word, where you've got
Yep.
your OEE. You're not letting your the model do the calculation of the OEE. You've got the skills like a
Mm.
Python script that is specifically built for calculating OEE, and
Yep.
and sort of like let the sort of like the model handle other stuff that doesn't involve the actual arithmetic or things like that. Can you speak to us about how you sort of like determine how what goes into a skill, or what goes into MCP, or what goes into the actual model sort of like prompt as it were?
Yeah, no, absolutely. That's a great question. Yeah, I'm glad you pointed that out. So, we for the last 30 years, we've been developing best practices around writing like deterministic code, right? So how can I write code that's always going to execute the exact same way every time? And we've built a lot of infrastructure around that with testing and, CI/CD and stuff like that. Things like where we need deterministic behaviors, things like calculations, or maybe, we need more deterministic behavior. An agent always has the potential to hallucinate or do the wrong thing, right? It's a probabilistic model. We can engineer things using context engineering and, some other tools to try to reduce the amount of hallucinations, but there's always the chance that it's going to do and call the wrong tool. Just like humans do. Like humans make mistakes too, right? Sometimes we just make mistakes. So where we like, kind of the thing I always tell them, kind of what I talked about in the workshop, is if you have something that can be done with a deterministic tool, it should be done with a deterministic tool. Don't use an agent to do a calculation, right? You write a script that you can validate the function's correct and that it's doing the calculation the correct way, and then provide that calculation as a tool that the agent can call, right? So the agent can say, hey, I need to calculate OE, but don't let it actually do the calculation. Write that as a script, or use like a deterministic piece of code that we can write and validate and check in, and just expose it as the tool, right? Where agents are really powerful is where deterministic code is like brittle, right? So for example, we've always had this issue with like doing semantic like clauses with code, right? Like, hey, if the user says this, do this, or if they say this, do some other thing, right? This is where an agent's really powerful, right? It can kind of have this fuzzy logic and determine based on the context, like what's the right thing to do, or, what's the right case to go down. That's why I kind of think of them as an orchestrator. But yeah, that the reason we do the deterministic tool is we kind of see a vision where not only we moving towards multi-agent, where agents are coordinating work and, sub isolating context windows and stuff like that, but we should also be writing deterministic code that agents can call as tools to do certain things, which is also a form of context engineering, right? We're kind of summarizing and producing only what the agent needs to know to do its job. It doesn't need to know how to calculate OE. It just needs to know what is OE at that specific time if it's generating like an OE report, right? Um, the so yeah, that's why we had the deterministic scripts in there. And yeah, to me, like when you're talking about, separation of concern and like, should I use a single agent for that or multi-agent? You have to remember every time you have multi-agent, you add a point where there can be misalignment between agents, right? It's always like a point where a hallucination can happen. So you kind of get to people kind of normally go through this like maturity phase where they start with like one agent and then they discover sub agents and then they try to like get too granular with it where they have like a sub agent do every like one specific step. The problem that we typically see is you end up having coordination issues with those agents, those sub agents. That's why multi agent is really hard to do. So it's always this balance between figuring out like, can this fit in a single context window for a single agent where maybe that agent needs to know all the context and we shouldn't sub delegate it out? Or is this better to have sub agents do this, coordinate them, because it couldn't fit in a single context window, right? There's kind of a balance between figuring out how to do that. And to me, that's why I'm like really big on knowledge graphs and like
Yeah.
knowledge models, is because thinking about what is a task, right? Or how do I define a task? That is what knowledge modeling is, right? We're kind of seeing this very popular workflow right now called research, plan, and implement. So agents typically follow like a research phase, and then once they have enough context of, doing that research, they create a plan. So like, what is the rationale for what I'm going to do? And then the implementation is an agent actually going and doing that work, right? But when you think about research, the research changes based off of like what type of initial prompt the user gives it, right? Like if I ask it to do a code, write a new feature versus debug a bug, that research looks very different, right? And then you have to start thinking about, okay, well, for the sub tasks that I'm having it do, what other context needs to be referenced? What other instructions should I be giving the agent? Things like that. And that's really where skills came in, right? So skills to me are that separation of concern, but they're really encapsulating logic for how to make decisions, essentially, right? A skill from Anthropic, you have a skill MD where you specify, this is how the agent should behave. So you might say like, hey, read data from the database, call this calculation tool, and then like generate a report. So you're kind of telling the agent what to do. In the skill, you might have the script for how to do that, and maybe some references to other like documents or forms of context. But the beauty of that is that skill is now packaged in a way that other agents can use it, right? So I can have all these skills and they can be very like modular and composable. And then an agent can just read those into the system context window to be able to execute it, right? So you can have this kind of like polymorphism with agents with things like skills because skills are encapsulated logic, which creates some really powerful design patterns. But yeah, to me, I get so excited about agents and like doing that modeling because it's very close to knowledge modeling, in my opinion.
Yeah, absolutely. So, I mean, would you consider skills to be uh, SOPs, something to capture sort of like SOPs? Uh, and because I see that confusion a lot between MCP skills and sub agents, and I've
Yep.
so sort of like watched someone kind of like give an example of a chef to say your skills are like the recipe. That's your recipe card, right? You need A, B,
Yep.
C, and D, and
Yep.
then the tools, the MCP is the tools that you need to actually cook that recipe, right? Or
Yep.
to sort of like cook that, and then your sub agents would be like maybe in case you need to have one chef who specializes on a specific cuisine, right? Then go off and do their stuff, and then you. So I find that there's all of that confusion to say, okay, but why would I need a skill? Where do I need a skill? Where do I need a sub agent? Because there's this
Mhm.
overlap, right? Like you said, and things like that.
Yeah, no,
So
that I think that's probably the main question that like most people have because like Anthropic has been releasing these new features and like other model providers been releasing similar features near the same time as, Anthropic or these other like Gemini with Google and stuff. But it's been releasing so fast that kind of the boundaries or the use cases kind of have some overlap, which kind of creates like this like gray area of like, okay, should I use an agent? Should I use a skill or a command, right? My opinion is there's many ways that you can do different things, right? My own decision making kind of matrix for that of how I kind of think about it is let's compare example a subagent to a skill. In a subagent, you can write the subagent definition to have the recipe for how to do something, right? You can, in a subagent definition, you can say, hey, go to the database, read the data, call this tool, you know, call a calculation, generate a report, just like you could in a skill. The difference with the subagent is it's going to be an isolated context window, right? When you use a skill, any agent can use that, right? So I can have skills that get chained. Like maybe I have a skill to read data, maybe I have a skill to generate a report. That will be a single agent that reads those skills in a single context window. Whereas a sub agent, even though we can have those workflows in the sub agent, it's going to be on a separate isolated context window, right? So when I think about when I use a sub agent versus use a skill, to me, sub agents for context management around like isolation, essentially, like isolating specific forms of context. Whereas skill is something like I want any agent to be able to run this at any point in time, right? That's like where a skill is really powerful. MCP, to me, the difference between like an MCP and maybe a skill is if you think about an MCP, and this is actually one of the drawbacks with, and people have been talking about the bloat that comes with MCP servers, right? Is when I connect to an MCP server as a user, I don't have to write any of that context, right? I connect to the server and the server is supplied to the client via the MCP standard, right? So all the tools have tool descriptions. The vendor that has written the MCP server, they're going to add all the context of, hey, this is what the tool is, this is how to call it. And sometimes they aren't as efficient with your tokens and you get MCPs that have, tons of tools or the tool descriptions are really big, right? The main problem with MCP is that when you connect to the server, it loads all those tool descriptions and all the tools all at once, right? So you can end up with like consuming 20% of your context window just by loading MCP servers, right? I think that's why a lot of people that have tried to, they wanted to have an agent that had like 100 tools, realize like, oh, this is causing more hallucinations because they were using so much of the context window just for the MCP connection. But to me, like that's the main difference between MCP and with skills is uh, the MCP, the context is generated and supplied by the server or by the vendor. And as a user, I just consume it, right? With the skill, I have to write, as a user, I have to write the context, right? I would tell it, hey, call this API, and this is how you create the API. So yeah, you have more flexibility in how that agent behaves, but now I have to define all the context that the agent's going to need to know how to use that tool, right? So it kind of shifts the delegation or the ownership of the context away from the vendor and more to like the user, right? And sometimes that's like really powerful. Like if I want to have very granular control over how an agent uses tools, like I like to use skills for that. But sometimes I like using servers because I want that context to be supplied by the vendor because they've built the tooling and they know how to use their software, right? So to me, I think that's why we're gonna see a world where we see MCP and skills is they have different use cases, right? The other thing with skills is they have the ability to progressive disclosure, right? So when you look at a skill, there'll be kind of two sections. There'll be the content section, which is what the agent eventually will read, but then there's a YAML section that has like a system, a skill description, and maybe some other metadata there, depending on how you defined your skill. When you load that in, the agent doesn't read all of the content from the skill MD, right? It doesn't read the full long description and all the references and scripts all at once. What it does is it loads just the YAML portion of that skill description into the context window. So when the user says, hey, I need to generate a report, it'll look through skills and say, hey, I have a skill called generate report. Maybe I should call this skill to do this work. And then when it does that, it will then load the full content of the skill. So skills kind of have this like progressive disclosure where MCP loads in everything all at once. But yeah, to me, the main difference is MCP is about supplying the context from the server to the client, where a skill the client has to define all the context for how to use those tools, right? But there's a lot of overlap between the three, right? But that's just kind of how my personal kind of decision matrix of how I think about them.
Absolutely. Yeah. So, and for someone who's listening to this and they're sitting, with a use case, they want to build an AI agent. What does that structured, repeatable workflow look like for building agentic systems that can actually work reliably in production?
Yeah. So a lot of it comes from managing that context window, right? Being able to make sure that you're only filling it with highly relevant information and none of the bloat. And again, that comes back to knowledge modeling, right? How do I know for a task that I ask an agent to do, what is the relevant information, right? Where is that coming from? How do I get that? A lot of organizations, they have tribal knowledge because they have people that have been in industry 10, 20, 30 years. We've always known that we need to address tribal knowledge, right? We always kind of known like it's kind of an issue, but we never had a forcing function around it, right? We've always kind of done on the job training. Someone comes in, they shadow the senior for, a week or two, and then there's like kind of knowledge transfer that way. We've never like had to like actually formalize and document and model that knowledge. With agents, we are having to do that, right? Agents can't do on the job training, reinforcement learning they can, but with modern agents that we're seeing with LLMs, the context needs to be digitized and then packaged in a way that the agent can reason on, right? So to me, when you're thinking about building a reliable agent, one is how are you going to design the agent to be able to manage its context window? But more importantly, what's the information architecture or the knowledge architecture around that agent so that it knows, what information to supply that agent when you're defining things like the skills and things like telling it what to read or what documents to reference and stuff like that. So a big part of it is like building the information architecture around the ecosystem, right? And kind of doing that knowledge mining is a skill in itself, right? Thinking about how do I decompose a task into subtasks and what are those subtasks? Like, what does that actually look like? And what context does that come from? And things like that. The other thing that a lot of people that I always tell people is we should be treating agentic like resources as code themselves, right? So we have prompts and skills and sub agent definitions. Those should be source controlled. We should be evaling those things so that when we make changes we can see are they improving, are they getting worse, right? We should be able to write higher level prompts and lower level prompts that reference one another, right? And then being able to compose prompts into like orchestration chains, right? So I think a big part of like what people should do is start seeing your prompts and skills and things as like kind of a digital artifact or a product that you should manage and iterate on and get feedback on and source control and test them and things like that. Because to me, that's going to be the big difference between people that are spending a lot of time with agents now and people that are not messing with agents right now. Is the people using agents now are building out those prompts. They're building out those skills and definitions. And more importantly, it's the people that are building them are developing the skills for what makes a good skill. How do I structure that skill? What information should go in that skill, right? I think that's going to be a big kind of expertise gap in the coming years, right? But I would say that treat agentic resources as code and figure out how to iterate and evaluate and things like that. Think about your information architecture, how to structure the data, how to get tribal knowledge out of different domain experts and digitize it into a way an agent can reason on it. And then the last one is set up pipelines that help manage that context window. Sub agents and isolation and when to use a sub agent and things like that. So that would be kind of my advice, those three main points.
All right. So now I want us to take sort of like zoom out into a more bigger picture to look at the data architecture for really, operationalizing, AI agents at enterprise scale, as it were, because building an agent for a specific line or site where it's accessing tools and skills within one environment is one thing, but it's sort of like zoom out and want to sort of like build out across your entire enterprise, multiple sites, multiple frequencies, and be able to reason across the same data infrastructure. That requires a well thought out data architecture as it were. Do you have some thought on how companies should approach that aspect?
No, yeah, absolutely. So again, it goes. I think we're gonna start seeing knowledge models, and specifically knowledge graphs, start to become very popular, right? I know we've already seen a little bit of buzz around that, but I think it's gonna ramp up, especially as people realize the data is really the key thing to operationalize agents. It's not necessarily the model. Models will get better, but it's really the infrastructure around that and the context and data that we supply them. But to me, I see knowledge graphs becoming a lot more popular, right? So you can think of, something like a unified namespace or, you know, a model where any model where we only have instance data, right? So we have like, payloads coming in, we have objects like equipment or an area or enterprise, right? And we actually have properties on those objects. And there's actual literal data on those things, actual values on there. There's some things an agent can do by reasoning on that, right? It can look at the name of the object and then look at its properties and say, okay, this looks like a filler or a capper. Like that's probably what it is, right? But there's no like business logic on that data, right? There's nothing telling it how the filler is related to the capper. And if there is, like, usually it's like a foreign key or something, some type of like implicit relationship. That's It's really hard for agents to keep track of some of those things, right? So there's only so much that you can do by just looking at structure. And also, as instance models grows, imagine if that unified namespace or whatever your instance model is, it's probably not that big of a deal for an agent to reason on that if it's small, like maybe, a few production lines. But you imagine a huge enterprise with multi-site, multi-area that maybe has thousands of pieces of equipment. That instance data, it becomes such a large size. The agent's gonna lose kind of awareness of where it's at in that data, right? It doesn't know. It just sees like all these values. One, it's gonna fill up the context window, but it's not gonna know how to rationalize and reason on that data, right? And that's why I think knowledge graphs are gonna become a lot more popular in the coming years. Is knowledge graphs have two main components. They have an ontology, which is basically a model of meaning. Uh, it describes the domain, right? So instead of like having just data of like your factory, it says, hey, this is what the production lines actually are. This is how they're related to one another. This is how resources flow to them, right? It adds a conceptual model or a model of meaning to what the factory is. And the other part of a knowledge graph is the instance model, right? So you, instead of just the instance model, you have these two components working together. You have this, meaning model, and then you have this instance model, and there's relationships between the two. So you can be looking at an instance of a filler, and then you can go up to the ontology and say, okay, oh, filler is part of a line, and on this line there's also cappers or things like that. It provides a zoomed out uh roadmap of the domain. And now that agent can go back to the instance model and say, oh, like this feeds into some other piece of equipment. Let me find that data, and be able to query it, right? So the ontology really becomes kind of not only helps it reason, but it provides a map of where to look in the instance model, right? So these knowledge graphs are going to become a lot more popular, and the explicit relationships that get formed between nodes and also between ontology and instance models, they add a lot of semantic value in terms of, defining, what is something, what, conceptually, how are things related. You can do entity name resolution. You can do some of these things that are harder to do with traditional models that agents are able to reason on because there's explicit relationships and there's a lot of added context in the form of the ontology of why the data is the way that it is, not just what is the current state and like what is the current snapshot or what is the state stateful information in the instance model, but like why is that data the way that it is, and how are things related, right? So to me, that's where I see things going. But first we have to digitize that tribal knowledge so that we can define ontologies, right? Because
Yes.
defining ontologies is challenging. There's a lot of thought that goes into it and a lot of knowledge modeling that goes into defining ontology. And I kind of see that as an expertise gap that as an industry, we're gonna have to figure out how do we kind of bridge that. But it's 100% needed for agents to be able to reason on and to be able to provide them the context and the ability for them to find the context that they need on a very big domain.
Yeah, absolutely. Yeah, I mean, I think knowledge graphs are already becoming popular, and to your point, I don't think we've got enough expertise, but specifically in industrial domain to to know how to exactly deal with knowledge graphs and things like that. So still we're going to have a huge skills gap as far as that is concerned. The other topic that I wanted to get your take on uh, quickly is because I speak to a lot of people on this podcast, and I sort of like noticed there's a tension uh, between the other group that says, well, actually, you need to build out a full model of your enterprise, because before you can actually make use of your data, you need to like really build out a full ontology, even ISO 95 based ontology of your entire enterprise. And some will argue that actually, with the rate at which AI is advancing, you don't actually need to build out that model upfront. You can just contextualize the data at the edge, and add whatever context you need to do, and just push it out into a data platform, and then you can figure it out from there. Where do you see what's your thoughts on what companies should do as far as modeling is concerned?
Yeah, I see the I understand why people want to make upper ontologies and have that model up front before really defining it. Because humans love structure, right? We like to have everything orderly and structured in a way that makes sense to us. But I mean, look at organizations to be able to use a model. You kind of to be able to define a model, you kind of need to know how you're going to consume the model, right? The problem with upper ontologies is more of a social one, and the fact that at a large enterprise, there isn't one person that knows the entire operations of that enterprise to know how to structure that data, right? Most people know their specific areas, right? They're domain experts in a specific subdomain, and they know that really well, and they know everything about that, and they know how they need to consume data and how to structure that data for their own data needs. But when you ask, hey, how is this domain related to this other domain? Most people have blinders on, right? Because that's outside of their day to day. So I think even though like it makes a lot of sense to create upper ontologies, it's really challenging to do so because there's just not anyone at a company that really knows that knowledge, right? To be able to model that. My opinion and kind of thought about it is we need to define the data models, kind of like from a social point of view. So kind of Conway's law. The way I see is federation. I see federated knowledge graphs being really valuable, right? Federation is the idea of that you're going to have domain experts that define models for their domain, and those models are used for their data needs. So you imagine a big enterprise, you might have a domain for manufacturing or engineering or quality or whatever. They're going to have like kind of their own models for whatever they need data for and their own reports or whatever. And then at some point, there are going to be relationships between those domains, right? There's natural integrations between them. There's also terminology or semantics that domains have that maybe they're using the same name for something, but conceptually it's actually something very different. Or maybe they're using different names for something that conceptually is the same thing, right? With knowledge graphs and federating them out, you can do entity name resolution. So you can basically model that, hey, these domains, they're going to call them something different, but realistically they're the same thing. Or no, they're the same term, but they mean totally different things. You can model those kind of things. Um, but yeah, to me, I'm a big person about federated knowledge graphs because I just see that's how my time at Northrop Grumman, that's how I saw, work centers and different cost centers like working is people knew their specific area. There just wasn't one person that could know how to model all that. So it's more of this federated and integrate. And then where I think you need to govern is on the interfaces, right? The natural, the QA domain or whatever domain doesn't necessarily need to know the domains how they structure another domain's data because that's outside their domain. But there might be integrations. Those integrations should have governance on them, right? They should have basically an agreement between domains around what the schema is, if the schema is going to update, what that process is. These are kind of the standard things that go into modern data architecture around data products about defining SLAs, defining schemas, things like that. But if you're going to do a federated knowledge graph, which I think is aligns with more of how organizations work, you have to implement governance. And to me, where it makes sense to implement that governance is at the interfaces where the domains integrate with one another. So that's kind of my take on it.
Absolutely. Yeah, so they kind of like just bring it back to what you and the team at Flow Software are building. So can you kind of like talk to us about the different? I think you mentioned Timebase. You're focused on Timebase, but I know you've
Mm.
also got uh, Flow AI Gateway that you put out sometime last year, I think, or a year before that. Can you kind of like give us a sense of how of your the platform itself, and
Mhm.
then also how you enable companies to build industrial agents on top of that data backbone that you provide.
Yeah, no, absolutely. Yeah, so I'd mentioned, Info Hub is our main solution at Flow that we've developed, and the main value proposition of Info Hub is to take data that is typically not aligned, your time series data that might be sampled at different rates, or have different sampling periods, and then aggregate them into event frames that are easy, that do aggregations that are easier to relate to things like a work order, or not non-time series data, right? So it's a way to define like aggregates or analytics in a way that makes it easier to publish back into the something like a unified namespace and like contextualize with other data. So you can think of it as like an analytics platform. Timebase is a new product line that we're developing, that we released the historian already, and the historian's free. The historian is mostly released because we saw a lot of people that didn't have an historian. They weren't persisting any data, and to do analytics, you have to have persistent data, right? So we wanted to create a historian. We wanted to create as little friction for people to get started, with Industry 4.0. So, kind of this historian the time-based historian, we released it to get people started, and that's the first product. And we have the collector for that, and then the explorer, which is the trending tool for the historian. But really there's the concept of like metadata inside the tags, inside the historian. So the historian has a concept of a tag, and you can associate metadata with it. There's not a lot of modeling outside of associating metadata with the tags that you can do. So that's kind of the next product line that we're really building. We're building out Time-based Atlas, which is it's a continuation of Info Hub. So we plan to have user-defined calculations and expressions and things like that. But instead of having a traditional hierarchy model, we want to implement a knowledge graph model. So users can define their data, and then that data gets put into a knowledge graph, where there's an ontology and then an instance model. And then the instance model connects to different data sources. So you could have data coming from the time-based historian. We're gonna one SQL database, REST, like kind of the traditional data sources that you would imagine. That's gonna populate your instance data. And then that data now becomes, in the structure of a knowledge graph, something that makes it easier for not only humans to reason on, but also agents, right? We talked about the knowledge graph and the ontology and how that provides the map. So that's kind of the time-based Atlas product that we're building. It's a knowledge modeling tool for data integration, and analytics, essentially. And it's being designed so that both humans and agents can reason on the data structure, which is why we went a knowledge graph approach. And then the AI gateway, right? So we're building out MCP servers on all the services within Timebase Atlas. So or Timebase, so the Historian, Explorer, uh, the Atlas will all have an MCP server on them. But we have plans to add other things like an MCP gateway. So you can imagine if you want to add permissions or track usage, or let people supply some tools to some subagents but not others. You might want to control that through kind of like what would typically be an identity provider, but it's for agents, right? It's through MCP. So we're kind of looking at some of the tooling around that and what that would look like, of like an MCP gateway, right? But the AI gateway is this really principle that it's not just MCP, right? It's a bigger ecosystem around that. It's MCP. We're talking about skills, having vendor supplied skills that we supply to users through Timebase, so that they can load them into their own agents and clients. So they don't have to define them themselves, but then they have control if they want to modify them, to make things a little bit easier and have that progressive disclosure, right? So the AI gateway is more kind of that higher level ecosystem of everything that's going to go into that. I will say a lot of what we're doing at Flow is thinking about context engineering, right? So when we designed the MCP server, we thought a lot about context engineering and not bloating the context window and how do we do like research plan implement and things like that. So a lot of the things that you'll see in our products kind of have some of that context engineering baked into it to make sure people are able to get the performance and the reliability by using these products, right? You get the reliability by managing the context window. So you'll see a lot of those kind of principles that we're talking about actually implemented in the products for people. But we like talking about them because we think it's really important for people to be aware of these concepts, right? So they understand
Yeah,
why the products are designed the way they are.
absolutely. I mean, we've run out of time, but before I let you go, just quickly to put you on the spot here. As a tradition on this podcast, I ask our guests to give us a prediction of what factory floor manufacturing would look like in a few years.
Mhm.
Just wild prediction, or where do you think things are going?
Yeah, that's a good one. I think I always joke with people. I think with AI right now and the rate of change, it's probably actually easier to predict things that won't change than
Okay.
things that will change. I think so much is going to change over the next, 3, 4 years. In terms of manufacturing, I know a lot of people are very worried about, job security and, agents coming in and kind of taking over jobs. My future and what I think we're going to see with agents is more of this passive like hybrid team, right? So you're going to have teams of like humans and agents and maybe they're integrated in a way that it makes it even hard to know that you're working with the agent, right? Agents might be messaging you on Teams or like getting context through traditional human type of communication channels, right? But my hope and kind of where I see industry going is agents being more of this passive thing that's happening in the background, right? Where it's collecting information, it's providing insights so that when you make a decision, you don't have to go create a dashboard and then try to get data access to do that, right? You just say, hey, I have this problem. And all this information agents have been running in the background that it just is there when you need it, right? So I see kind of agents being this kind of passive thing that add a lot of value, but they're really augmenting humans and they're part of the team rather than them becoming the team, right? I think there's absolutely things that we're still going to have the human oversight on things with guardrails, especially in manufacturing where safety is such a big concern, and determinism is such a big deterrent. But yeah, that's kind of my hope for industry is where AI is very kind of in the background where you're not really like thinking about it, but it's providing value and it's giving you insights like not only where you need them, but when you need them to the right person, right? To be able to help them make the decisions they need to make. So that's kind of where I see industry going.
Fascinating. Thank you so much, Zach, for taking the time to join us on the show here and for sharing some really valuable insight. As I mentioned, I really enjoyed walking through your workshop, the report that you put out. So we're also going to share that link for our audience. Anyone who wants to play around with this and kind of like get a feel of what context engineering actually is, just go ahead and download and kind of like clone the repo and play around with it. And we're also going to provide links to Zach's social and also Flow software website for all those who want to get in touch. So thanks again, Zach. This has been such a fascinating conversation. I really appreciate your time today.
Yeah, no, absolutely. Thanks for having me. It was my pleasure.